Okay, so good news today. This is our last day of looking at factoring. So I guess the good news is our last day of looking at factoring. Our bad news is when we come back from break, we'll be doing more with factoring, applying factoring, but not adding anything as new information. So today we really just want to sort of tie everything up in a bow, okay, with all of our information that we've learned about factoring and how we can make sure we're factoring completely. So our real goal today is prime factoring polynomials and getting them completely factored with all of those skills that we've learned. So putting things together, what we've sort of summed up over the last couple e-learning sessions is our first step is always going to be to factor out a GCF if we can. Okay, if there's no GCF, obviously you'll skip it. Okay, our second step is going to be to look inside the parentheses if we factored out a GCF, or just look at the polynomial in general and count the number of terms. Okay, and if there were 4 terms, or if there are 4 terms, that's our situation where we factor by grouping, right? And grouping is where we split in half and find the GCF of each side. If there's 3 terms, we're going to check for a trinomial. There's 2 terms, we're going to check for a special case. Okay, and then we sort of found this out in our last lesson that we always kind of need to double check ourselves, because once we factor a trinomial or we factor by grouping, then we end up with binomials, and binomials can also be special cases. So when we're done doing any of this, we want to check for any missed GCFs and or, I guess, any special cases. Okay, that's just sort of summarizing everything we've looked at. So let's say we're given 6x squared minus 2x minus 20. And we really, truly want to prime factor this, right? We're factoring it as far as we can, doing all the factoring that we can. The first thing that we're going to do is we're going to ask ourselves, is there a GCF? Okay, the answer to that is yes, we have a GCF of 2. So I'm going to pull out that 2. So we factor that out. That will leave us with a 3x squared minus x minus 10. Okay, with our GCF out in front. Then we're going to look inside the parentheses. So now I'm changing my focus. I'm looking here. Okay, I'm going to count the number of terms. So this is 1, 2, 3 terms. So 3 terms is telling me to check and see if there's a trinomial I can factor. So to factor a trinomial, we're doing A times C. So 3 times negative 10 is negative 30. So let's start listing our multiples to see. So 1 and 30, 2 and 15, 3 and 10, 4 and nothing, 5 and 6. Okay, with this setup, right, we need 1 negative, 1 positive. We need our larger one to be negative. Okay, so 5 and negative 6 are what's going to give me that negative 1, right? There's really a 1 sitting right here. Now, A does not equal 1 here. So I cannot factor this as the shortcut. I need to split this up into its 2 pieces. It's a positive 5x and a negative 6x. Right? I never promised anything about these problems being short. Okay, so now we have 4 terms and we can split that in half. So over here our GCF is x. And over here, right, our GCF is 2, but the leading one is negative, so we want negative 2. So this will give us an x minus 2 and a 3x plus 5. Okay, now we can't forget that 2 is still up there as part of this. So this 2 is coming down. Now we want to check and see in the two binomials, did we miss anything that's a special case? Or is it possible that there is a GCF still remaining? Nope. So we have this factored completely. And we have 2 times x minus 2 times 3x plus 5. Okay. Now, this is a relatively short one if we're really truly factoring completely for some of these problems. Okay, so let's say we're given 24 x to the 4th plus 56x to the 3rd minus 6x squared minus 14x. Okay, so again, we always want to think about, is there a GCF first? So what's something we can think of that will go into 24, 56, 6, and 14? Well, there is a value, so this has a GCF. Okay, do they all have the variable? Yes, so we can pull out a GCF of 2x. Okay, so when I start dividing, right, I'm dividing each of these. All 4 terms are getting divided by that 2x. So we'll get a 12x to the 3rd plus 28x squared minus 3x minus 7, right? These x's cancel. Okay, and so now I'm here with this GCF out in front. Then again, my next step is that I'm looking inside the parentheses. That 2x is already a factor by itself. Okay, so I'm gonna look inside the parentheses and I'm gonna say, okay, how many terms is it? Well, this is 1, 2, 3, 4 terms. So my next step is then going to be, okay, 4 terms I want to consider grouping. So grouping is where I split this in half. Okay, so we want to think of a number that will go into 12, that will also go into 28. We can pull out a 4. They both have the variable. The smaller one is the 2. So that's going to leave us with a 3x plus 7. Right, there's a lot going on, so don't cram your work together because you kind of need to keep everything straight. Okay, so over here we're pulling out a GCF of 1, but again, the leading one is negative, so I'm pulling out a negative 1. Okay, so just these 4 terms now factors into a 4x squared minus 1 and a 3x plus 7. Okay, now we don't want to forget that we have this 2x still out in front, so that's still part of it. Okay, and then we're going to look, did we miss any GCFs or any special cases? Well, yeah, this one we do, right? If we look right here, 2 terms, it's subtraction, and these are both perfect squares. Okay, so now we're ignoring here and here, and we're just looking at the 4x squared minus 1. Well, what number times itself gives us 4? That's a 2. And we're taking half of the exponent. What number times itself gives us 1? So this is going to be a 2x plus 1 and a 2x minus 1. But again, we can't forget those other factors, so that 2x is still coming down, as is the 3x plus 7. Okay, then let's check again. Do we have any remaining GCFs or any remaining special cases? The answer to that is no. And so here we are factored completely. Okay, now, saying that, again, I keep kind of reminding of you this every video, does not mean that every problem is terribly long. Okay, it's very possible that we could get something like 7x to the 3rd plus 5x squared plus x. Okay, so let's go down our list. Does it have a GCF? Yes, this has a GCF of x. Okay, so we divide that out, which leaves us with the 7x squared plus 5x plus 1. Okay, so that takes us here. Then we're going to look inside the parentheses, and that's 1, 2, 3 terms. So trinomial, 7 times 1 is 7. So we're going to list our factors of 7. 1 and 7 is it, right? So are we going to find anything that adds up to 5? And the answer to that is no. Okay, so that just tells us that this is a trinomial that can't be factored, right? It was okay at the beginning of this unit to just factor out a GCF, and we can't go any further. Just like if we're given a really weird larger number and we're not sure if it's prime, right? We kind of already know that 2 is prime, 5 is prime, 7 is prime, right? But as we start to get to larger numbers, we might have to kind of keep dividing to make sure nothing else works. I mean, that's just what we have to do here, right? We just have to try it out. Nothing else works. So we know we can't factor that any further. Okay, then last problem. X squared plus 16. Okay, so let's take a look. Does this have a GCF? No. How many terms is it? 2. Okay, so let's consider a special case. Is this a special case? If you're already thinking yes, nope, stop yourself. This is a no because this is an addition sign. So while it's 2 terms and they're perfect squares, we have an addition sign, so this is a no. We can't factor this at all. And just like 5 is a prime number, there are polynomials that are prime numbers. So when we've gone through our entire list, there's nothing that we can do. We will say that this is prime.